Hi everybody, I'm here today to share a little interesting things about while playing with circle packing in Rhino, Grasshopper, Kangaroo. Usually we try to pack circles inside our shapes and the little tricky part is to calculate the correct amount of circles for our shape. So we need to use a formula that takes the area and divide with the proper circle packing ratio, and we can find some formula on the web. So when we have the correct formula, we can change our radius and still have not too little and not too much circles in our shape. And so the circles more or less touch each other, and it's a good circle packing. The interesting thing is when we instead try to increase the radius anyway, so we sort of increase the pressure inside our circle packing. For example, like this, we already done this pretty much. We already anyone know these things, but it's pretty fun to see. It's funny to see. So we can see some pattern changing from hexagon to squares changing. For example, if we just look to one circle, for example here with normal pressure, zero pressure, the circle packing at zero pressure, each circle should just touch other 6 circles. But if we increase the pressure, now the white circle is being touched by 8 other circles, as this leads to change of the pattern to squares. If we still increase the pressure, it's going to change again at 18, more or less. We can see with 18 the pattern changes again to hexagon, triangles. If we increase once more, we shall see with 20 we have again the square pattern and so on. So this is quite interesting. It's similar to maybe allotropic state of a crystal or a metal or a different phase of ice. Similar, I don't know. And it's cool to see the actual Voronoi of these things with specific color for hexagon, pentagons, squares, and so on. And we can see different different phases of the crystals. And let's have a look. Increasing the pressure going from hexagon to squares. If we still increase the pressure at 1.6, yes, we have half hexagons, 2 pentagons, couples of pentagons. At 1.7 we have some triangle. Going up we have these small clusters of 9 elements each, sharing elements with neighbor clusters. Going up with the pressure, again some different pattern, and going up to hexagon again. Going up again, square again, squared pattern, squared grid. Up again we have these interesting, which have some granular patterns of octagons that do not touch each other. So it's another phase, another allotropic state maybe. Going up again, we can find again the half hexagon, but this time are more squished. And the more pressure you go up, the more different pattern you see. Some are cyclic, periodic, like normal hexagon. But if you go up, you can see, for example, squished hexagons, elongated hexagons, and so on. Then when the pressure is too much, it's going to be mostly randomic results. Now, the interesting things is that we maybe can replicate some kind of quenching. For example, if we have enough elements and starting from zero pressure, normal circle packing, and gradually increase the pressure going to 1.7, we have some triangle here. But if we go up to the next phase, next state, wait a bit for a relax, and then going back, we have bigger chunks of triangle pattern. So maybe this is like changing the pressure, changing the density of the pattern, but going from one to another lets us achieve different pattern. Let me try again. One dot seven. We have some triangle, but disrupted. Going up. Let it relax a bit, and then going back. We have bigger areas of same structure triangles. So I don't know, maybe this is interesting, maybe this is probably this is completely obvious for people who work in these fields, for metallurgy and so on. Maybe we should try similar effects in 3 dimension. This is just bidimensional. And that's it. Quite funny. Let me know what you think. Sorry for my bad English. Have a nice day.